Hello everyone, welcome to the session of Engineering Graphics. In today's video, we are going to learn how to solve problems on isometric view. These are the two views of a simple object, front view and top view. I have marked all horizontal lines in front view by letter L because these will go parallel to length. And all vertical lines in front view we have marked by letter H. In the top view, all horizontal line again will be parallel to length. Therefore, we have marked these two horizontal lines by letter L. And vertical lines in top view will go parallel to width. That's why we have marked these two vertical lines by letter W. It is convenient to mark all the lines by different letters, that is LWH, for our convenience. Now, first of all, we shall draw the different directions for the isometric view. Now, vertical direction is a height direction. Height. And this is the length direction. Length will be to the then see, entire view, it has occupied the space available to the right of origin. Therefore, we are supposed to take length to the right of origin. And width to the left of origin. If right side is length, then left of origin will be the width. Of course, these two angles are 30 degrees. Now, to draw isometry, first of all, we have to draw horizontal line. Then take origin on this line. We shall take origin somewhere here. Now we are supposed to draw two lines starting from origin at 30 degree angle. One for length and other for width. Line at 30 degree. Line at 30 degree again. Now length for the given object is 60 mm. Therefore, let's take this is a length and width is 50 mm. Somewhere here. And height is 10 mm. Right. We have drawn these three principal lines, basic lines, which we call these lines as isometric axis. See, this line it has already been drawn. This line it has already been drawn, that is width, and this line it has already been drawn. Now let's draw remaining lines to complete the object. Now I want to draw this line. To draw this line, I should go parallel to length, that is this direction, length direction. I have drawn this line here. Let us draw a line at this level. See, this line is at bottom and the line which is above this point, it will coincide in top view. That's why let us draw a line which is parallel to width. Let's draw this line. See, this line is here. Now let's try to draw this line. To draw this line, I should go parallel to length. Now to draw this line, I should go parallel to width from this point. This completes the. Now let us make this object little bit complex to understand more concepts. I am adding one more plate to this. This height I have taken 40 mm. See, I have added this part. This I am taking 40, such that total height would be 50 mm. Because of this addition of part, there will be some modification in the top view. Now let's try to draw isometric of this additional part in this object. Now I have to extend all the vertical lines by 40 mm. And let's draw two lines which are isometric lines parallel to principal lines, that is isometric axis. Now I want to locate this point. Let us take this width as 10 mm. See, this point, it is here. To locate this point, I should go parallel to width by 10 mm. In this way I got this point. Now to draw this line, I should go parallel to length, as this is horizontal line. Now, if this is the thickness, there should be vertical line at this point. Here also, rear side. And here. This is the isometric of additional part. Now let's make one more modification. I will chop out this corner, keeping both these dimensions same. Now see, this point is here, and let us try to locate this point and this point. See, to locate this point, I should go parallel to length by 10 mm. Therefore, this point will be somewhere here, 10 mm. Now let's locate this point. It is 10 mm below from this. It is somewhere here. Now if we join these two lines, we will get this non-isometric line. because it is not parallel to length, height or width. Once we get one line here, there will be another line to the rear side, that is back side. The projection of this, if we chop out this portion, its projection will be this. To draw this line, we should go parallel to width, as this line is in top. This is the line parallel to width. There will be one more line here parallel to width. If we join these 2 points, it will be by default parallel to this isometric line, non-isometric line. This one more feature we have added here. Now, again we will go for further modifications. We will provide a slot here. See. I have given slot here. See, I need to change front view also. Yes, I have to add a hidden line for this. Now, let's take this dimension as 10 mm. This again 10. And let's take this as 20. And not to mention this dimension, it is again 10, as this is vertical line which is parallel to width. And let's take this 10, and not to mention, because total length width is 50. 50 minus 10 plus 10 plus 20, that is 40, is 10, and not to mention this dimension. Now let's try to locate this point. This will be at 20 mm distance from this corner. From this corner, 20 it has already removed. Sorry, 10 it has already removed. Now let's add 10 more millimeters, so that we will get this point. Once we get this point, we have to go inside by 10 mm. As these horizontal lines are parallel to length, we have to go by 10 mm in length direction. Then we want to draw this line, 20 mm line. For that, we have to go parallel to width, in width direction 20 mm. Then let's draw this line. For that, we need to go parallel to length. Now this hidden line, it will be here, the dimension of which is 10 mm. There will be line here, here, parallel to length and parallel to width. Again we will go for further modification. See, this plate, let us give some additional feature, that is a drilled hole inside this part. See, this 10 is deducted from total height 15. This total height is from here to here, it is 40, and at 20 mm we will take the center of hole, and we will take the hole of 20 mm diameter. This is the center point of this segment. 60 minus 10, it is 50. This will be at 20 mm or 25 mm. That is half of 50. And this point, it is at 20 mm. This from here to here it is 40. We are trying to get the center point as far as possible. Let us try to draw proper lines. And this circle is of 20 mm diameter. Now to draw isometric of this circle here, see, it is better to put this circle inside a square. Such that there will not be any confusion whether to draw rhombus in front plane, top plane or side plane. See, this is the square. The two of the sides of this square are parallel to length, and remaining two sides are parallel to height. Therefore, constructing rhombus for drawing isometric of this circle in isometric view, we need to draw two lines of rhombus parallel to height and remaining two lines parallel to length. Now let's draw two lines of rhombus parallel to height. As this diameter is 20 mm, these two distances will be 10 each. Now let's draw these two lines parallel to length at 10 mm distance. The side of the rhombus is equal to diameter of circle. Now then draw longer diagonal first. Join corner with midpoints. Join corner with midpoints. Then we got four centers. Using these four centers, we shall draw four arcs which will give ellipse, which is isometric of circle. With this center and this much as radius, draw an arc. With the same radius and changing center, that is this center, draw another arc. With this center and this much as radius, draw third arc. And with this center and this much as same radius, that is this radius, these two radii will be same. There will be arc parallel to this in the back plane. The depth of this plate is 10 mm. Therefore, to draw arc parallel to this at 10 mm distance, shift the center of this arc, which is here, in the width direction by 10 mm. And using old radius but new center, draw an arc. This completes isometric of the object. We are supposed to give only overall dimensions, that is total length, total width and total height. Total length is 60. Total width is 50. total height is again 50. It can be given here also. $50.